Well, we're going to focus, as this slide says, just on ionic bonding, like the chemical bond that forms in an ionic compound. And so my hint to you is to pause this if you want to, but get your periodic table handy. That's actually going to help you make sense of this. All right. So we talked about how electrons around an atom are what we call configured, how they're hanging out. We came up with electron configurations in Unit 2. This is Unit 3. We talked about special electrons, so I call these special electrons. They are the valence electrons. They are in the highest end. Do you remember that? Valence electrons. And valence electrons, as it turns out, when we talk about atoms joining together to form chemical bonds, it's the valence electrons that actually are most important when atom A joins with atom B. It's those valence electrons that make those chemical bonds, whether electron is transferred or electrons are shared. Electrons are shared. So you need to understand valence electrons, and I know it seems like, oh my gosh, don't make me write spectroscopic notation. Don't make me have to write electron configurations to know where the electrons are in the highest end. And I mentioned this before, and actually if you're talking about an element that is a main group element, a group A element, then you know the number of valence electrons simply by the group number. So this is in Roman numerals. I don't know how you're doing with Roman numerals, but 1A has one valence electron. If an element is in period 2A, okay, it has 2 valence electrons. 3A, it has 3 valence electrons, and so on. So I mentioned you need to have a periodic table handy for this lecture in order for it to make sense. So just to kind of make sure we're all on the same page, all these elements have one valence electron. I'm going to skip 2. They have 2 valence electrons. I'm going to ask you this question. Chlorine, how many valence electrons does chlorine have? The answer is 7 valence electrons. Exactly. Carbon, how many valence electrons does carbon have? 4 valence electrons. Isn't that awesome? Now I want to draw your attention to what are some names for these group 8A elements, these guys over here. Yep, we call them rare gases, inert gases, noble gases. So how many valence electrons do they all have? Exactly, they all have 8 valence electrons, and that actually, as it turns out, is a very hairy deal. These guys over the group 8A elements, they have 8 valence electrons, and they are what we say configured in NS2, that's 2 electrons, right? NP6, that's 6 electrons. Of course, 2 plus 6 is equal to 8. Oops. Okay, sometimes we'll call that an octet. And as it turns out, that octet, or 8 electrons, is a very, very important thing for atoms to want to get. An atom can keep its nucleus and kind of lose electrons and gain electrons and keep the same, it will remain the same element. But electrons actually are lost, gained, or shared to get a complete octet. So we're going to be talking more about that.